welcome back to my YouTube channel. If you're just coming across my channel for the first time, you're highly welcome. Kindly subscribe, like, and share. So here is question 2 in linear programming. So I've treated question 1 already. You can kindly check on my YouTube page for the full video. So the question states: a company produces 2 products whose input and demand requirements are in the following table. So we have this table. So we have the raw materials for product 1 and 2, labor per day, unit per day for product 1 and 2, the demand per unit per day for product 1 and 2, then the profit made is this value, and the maximum resources available for raw materials is 42, for labor is 60. A. Determine the optimal product mix using the graphical method is 13.5 marks. B. Succinctly explain any from the following linear programming terms or convention. We have the position variable, right hand side variable, the contribution coefficient, technological coefficient, then the site or structure or system constraints. So these are 4 marks. For this video, I'm going to only show the computation. Then in the subsequent video, I shall treat the terms and conventions of in linear programming. That is the terms and terminologies that are in linear programming. So in this question, we're dealing with profit. Even without being told, in this question, are we minimizing or maximizing? In my previous video, the question 1 I treated, what we did was on total cost. And as a business-oriented personnel, when you're dealing with total cost, you will make sure you try to minimize. Hence, that will be the minimization in linear programming. But in this case, you're dealing with the profit here, so you need to maximize it. Hence, the maximization in linear programming. So this question is about the maximization in linear programming without being told, because we're dealing with profit here. So I'm going to take you step by step on what to do when computing it. So step 1 shall be to formulate the above problem into linear programming model using inequalities. So let X represent product 1 and let Y represent product 2. So we have to maximize this Z is called that variable that should be maximized, which is 7 and 9, which is the profit. So to put them into the linear programming equation, that will be 7x plus 9y. So we are subject to. So what are the constraints? The constraints here are raw materials and labor. So the constraints simply means what are those factors that can be either hinder the process of production or further the process of production. For instance, now if the raw materials are not in adequate supply, it will slow down the process of production, and vice versa. And if labor is not in adequate, is not available, it will hinder the process of production, or it will slow it down. So subject to, what are the constraints here? We have the subject to raw materials. The raw materials here are 6 and 7. So for us to put them into a linear programming equation, that would be 6x plus 7y, which is less than or equals to 42. We are making use of the less than or equals to because this is maximization. When you are minimizing, the inequality to be used shall be greater than or equals to. But when you're maximizing,